Okay, question 2 asks us to find the square roots of this complex number here, and there's a root inside there already, but that doesn't affect the question at all. So don't panic if you see a question where they're asking you to find the square root and there's already a square root in the complex number. It's the same method, and you'll see as we go through the question that it all just works out absolutely fine. So if we're square rooting this, we can assume that the square root of it is going to be some sort of complex number. So if we say that we're going to square root it and say that we're going to expect some sort of complex number, our aim is to find a and b. So first step, I'm going to square both sides to get rid of the square root on the left so that we can start working out a and b. And then if we expand these brackets, we'll get a squared, we'll get plus 2abi, and we'll get minus b squared, because we'll get b squared I squared, but I squared is -1, so we're going to get minus b squared. And we can then compare that to the left hand side, because we can split it into the real part, which is the 43, and that has to equal the a squared minus the b squared, the real part on the right hand side, and the -6 root 10 needs to equal this 2ab here. So what we can then say is that a is going to be equal to -6 root 10 over 2b, or in a simplified form, -3 root 10 over b. And we can then substitute this value of a, or this expression for a, into the a in the left-hand equation. So we can say that 43 is equal to -3 root 10 over b, all squared, and that's why it doesn't matter that there was a square root in here, because we're now going to square it and it's going to disappear, minus b squared. And if we do square this, we'll get 90 over b squared. So next job now is we're going to times everything by the b squared, and we get a complex equation which we can factorise. It's not a complex equation, a kind of quadratic style equation. Even though it's got a power of 4, we can rewrite this as minus 43b squared minus 90 equals 0. Sorry, that's going to be plus 43b squared. If I add this on to this side, that's going to be positive. And then we can factorise this. Now you can use it, if your calculator factorises quadratics, you can use your calculator to factorise this with a b squared here. It's actually really straightforward. We can have if we take 45 and 2, that's going to make our positive 43 and negative 90. So we can hopefully now, you can see that b squared is either going to be negative 45 or b squared is going to be 2, which means b is plus or minus the square root of negative 45, which it can't be, because initially at the top here, when we wrote this, we assumed that a and b were going to be real numbers. So b squared can't be negative 45, but b can be plus or minus root 2. And it can be either of those, plus root 2 or minus root 2. So that's b. A was minus 3 root 10 over b. So if a is if b is plus root 2, then a is going to be minus 3 root 10 over root 2, which is negative 3 root 5. And when b is minus root 2, a is going to be plus 3 root 5. So, don't forget to actually answer the question. So the square root, so let's do that at the side here. So the square root of 43 minus 6 root 10i is, and we said it was a plus bi, so that's going to be 3 root 5 minus root 2i, or minus 3 root 5 plus root 2i. So you could, if you wanted to, you could write that as plus or minus 3 root 5 minus root 2i.